All right, I think some people might still be trickling in, but let's begin. I'm pleased that to have this outstanding group of panelists for our next panel. And this is on the topic of massive mobile broadband capacity gains through a combination of methods that will be discussed, including small cells, Wi-Fi, virtualization, 5G, massive MIMO, etc. So I'm pleased to have from the Small Cell Forum, Andy Germano, who will be speaking first. From Nokia, Brian Hendricks. From AT&T, Hank Kafka. I should actually give their titles. Andy Germano of the Small Cell Forum is the Vice President. Brian Hendricks is the Head of Technology Policy and Government Relations. Hank Kafka of AT&T is Vice President of Access Architecture and Devices. And John Kuzin of Qualcomm is the Senior Director of Government Affairs. So each has a prepared presentation that will take no longer than 10 minutes. And at that point, I have some questions that I prepared, and we'll also open it up to the audience. So without further ado, Andy.
Great. Thank you, Peter, and thank you for having me here today. I represent the Small Cell Forum. So we're an industry association of about 150 member companies, about 66 operators, 77 vendors, representing the full ecosystem from chips, software, access points, infrastructure. So just to kind of set the stage, some of you here have more experience with small cells than others, so I just wanted to start off with a little bit of a lead-in, what are small cells? And thank you, Inoue-san, for letting us know that 5G is still thinking about small cells, so I have a little job security there, moving forward. I was really happy about the discussions today. The other side today that was interesting is, you're sitting there and you're wondering, what is 5G, what's going on out there? But it seems a lot of the thinking that came up in this morning's presentation is actually things that are captured in what I'm going to talk about here. So just real quickly, the benefits of small cells is improved coverage. It's the original use case, real simple use case. You're in a room, deep in a building, or in a castle, in the basement of a castle. There's no bars, no signal there. You use small cells for coverage. This is the first presentation I've ever been involved in where it had the word massive in the title, which is great, especially for a small cell guy. So where this massive capacity, it's going to come from the capacity side of the benefit of small cells. So we'll talk more about how that works. And then, as we heard this morning in the presentation, using small cells has a really nice spectrum efficiency aspect to it, as well as new applications for location-based services and presence-based services. So this is one of these homemade charts with some really pretty charts coming up. I saw the Qualcomm charts, and they're beautiful, but most of these charts I got from somebody else, but this one I made myself, so forgive me. Anyway, this is like your cell, your macro cell, and we're talking about greater capacity. So, how many small cells are we really going to have in there? And does it make sense to have the small cells really close to the macro cell? Because the thing that drives is the interference aspects of between the different cells amongst themselves, as well as between the small cells and the macrocellular network. But we did a few studies, and we have a lot of real-world deployments. And the first thing that we saw here in this study, and this held similarly for 3G as well as LTE 4G, is that with about 4 small cells per macro cell, you're offloading about 56% of the traffic to the overall macro. So as the person mentioned this morning, I don't know if it was Brian or maybe Burge, was saying, it really makes sense to have a small cell in this room to serve us versus being served by the same macro cell that may be serving 1,000 people, because out of each one of those small cells, you're getting the same capacity. If with LTE, the original generation of it, you're getting 100 megabits downlink, 50 megabits uplink, from each small cell, you're getting that same capacity. So with only 4 small cells per macro cell, we can offload half the traffic, which means everybody gets a better experience. So anyway, this slide shows kind of more technical. One of the things we look at in wireless, and specifically with small cells, people have heard of signal to noise. This looks more at signal to noise plus interference, because the interference aspects of it, when you have cells close together or interacting small cells with macro cells. So we're looking at the bottom line is a typical macrocellular geometry, data rate in an LTE type network. This is a 4x4 MIMO, 10 megahertz network, where everybody's user experience across the cell is about between 5 and 10 megabits per second, whereas with a small cell, it's much higher. So that's just kind of an example of what you might expect in the real world. And I would expect, as we move to 5G, if you just look at small cell and this technology versus small cell and that technology for similar types of benefits of looking at a macrocellular versus small cell type network. This is where it really becomes important for the users is, look at those, got a little shifted in the transition, but with 4 small cells per macro cell, it's almost 500% user experience improvement. So if you press go on your YouTube or on your web page you want to download, it's going to just happen that much faster. Now the key trick with the small cells, there's a few of them actually, we can talk about that in the Q&A, but the most important one is putting the small cells in the hotspot, you know, where the traffic is, where the people are. We noticed in the same study, which was in downtown Paris, that if you put the small cell in a place where it's not necessarily a hotspot, you will double the capacity, but that's it. Whereas in the case where if you can put the small cell in the hotspot, you get these very significant user experience improvements, the 500% type of user experience improvement. So if Peter said we're only going to be allowed to have one chart, I would have these two. And I wanted to kind of waterfall through, but I didn't get the animation right. But you know, what are the primary benefits to get this massive capacity? So here's Andy's thoughts on that. So the first thing is interference mitigation. You know, as you're using the small cells, you really need to be able to manage the interference between the cells as well as between the small cells and the macro cells. So the original use case for small cells was coverage. Okay, in that case, there is no interference because you don't have any bars. You have no macro cell that you're seeing. So that was the easy one. So everybody talks about these release numbers. GSM release 8 was when the femtocells originally were defined, or home node B. And those were really, there's no interaction between macros and small cells. You just plug it in to your broadband connection, and then you're up and running. So what a lot of the work we've seen over these releases that are coming out now, like release 12 and release 13, is really, you know, working closely together more between small cells, but more importantly between the macro network and the small cell network. As we saw in the presentation, the keynote this morning, for 5G, you know, a significant part is having that working together between the small cell and the macro network. So we always talk about 2 types of small cells, co-channel, which is in the same channel. That's where interference is harder, and then also separate frequency. That makes it a lot easier. Maybe, you know, I talk about, you know, Walt Disney. We're building a new city. We can build it from the ground up. We know we're going to have 1 million people. It's going to be perfect. All the roads are going to be in the right place. What usually happens is we build the city as it grows, and then you get all these construction projects and roads too small and things like that. So if we could do it, I mean, small cells work great in high frequency, lower propagation, and macro cells work great in low frequency. But there's a lot of things to consider on these small cell deployments. But the second massive benefit is self-organization. And I think the keynote presentation this morning where you saw you have beams going this direction, there's a guy over here, he's not in the beam, you want to talk back to the macro network and steer the beam. These are the kind of things how SON, you know, needs to evolve further to let us get to those massive types of capacity. Along with a massive word, maybe I'm probably going to overuse this new buzzword of the day, is massive Mimo. We saw that in a couple of presentations this morning, I think on the keynote panel as well as in the first panel discussion as well as in the keynote. We're talking about Mimo, which I think is going to be an area. And then finally, NFV, Network Function Virtualization. So these charts are available on the website. I've got some backup charts on both the SON and the NFV topics if you want to look into a few further details. But when people think about NFV, normally they're thinking about commercial off-the-shelf computing hardware. So traditionally in infrastructure networks, you're buying Ericsson's equipment, Alcatel-Lucent's equipment, Samsung's equipment, Nokia's equipment, and each equipment maybe has its own function. So with NFV, one of the first benefits is you're looking at using server type equipment. Now that everything's in LTE, it's all IP-based type traffic, so you'll be able to save a lot of economics are much better in terms of being able to use this commercial off-the-shelf equipment and also allocate the same equipment for different tasks. We're extending that as well into the radio side. We talked a little bit this morning about Cloud RAN. People were talking about Cloud RAN. So with Cloud RAN, we're separating the radio electronics, maybe the antennas that are in the room, with the baseband electronics that are located somewhere else. And with this whole NFV, the benefit for the massive capacity increase is when you can move capacity around to computing hardware that's available. So at one point during the day, I saw an example from a Docomo presentation last year where they were talking about this area in Tokyo that is a nightclub area. It's very busy at night. Like the traffic shoots, extremely high at certain hours of the day. Same thing in Gangnam in Seoul, Korea. And so being able to use computing hardware that's idle in a different location is some of the benefits that we see coming from network function virtualization. And then these other areas that are in the topic for the panel, Wi-Fi. I think Birch mentioned the previous one. There's also LTE unlicensed, which can be in the same, leveraging free spectrum for capacity offload for what I call best effort applications. You don't have the full control of the spectrum. There's other users in there that may not be part of your licensed spectrum, but there's still a lot of benefit you can have from what we call offloading to this free spectrum. And these are some of the requirements. Some of the things we're looking at in Small Cell Forum are seamless login, using the cellular network to log you in, so you don't have to do the whole authentication, SSID. Channel bonding, where you might have a video download, very high capacity application. You put Wi-Fi together with the LTE, and it happens that much faster. And then some of these location and presence-based services. It came up, in this room in public spaces like retail, Tesco or Macy's or Starbucks. They don't want to put 3 access points or 4 access points, one for T-Mobile, one for Sprint, one for Verizon. But with Wi-Fi, it works, with everybody. So that's one of the nice things about that technology for these location-based services. And then spectrum sharing, I didn't really talk about it too much today. It came up in the last panel. This is where we're looking at new spectrum allocations, like the small cell band somebody brought up this morning. We need better techniques to get to 5G that allow applications to use underutilized spectrum. People have talked about white space. This is a similar type of a concept where there's a piece of spectrum, it's not being used at this moment. You go in and you use it, and there's some benefit there for getting to this capacity. And then finally, 5G. I originally had this, what is it? So I was glad to hear this morning that everybody was kind of in consensus. I didn't want to put that in writing, though, but now I'm on video with that, so just delete that part out. But anyway, I just called it the Internet of Things. I mean, we talk about today, there's how many people on Earth now? It's like 6 billion. And then, Ericsson was saying last year about 20 billion connected devices by 2020. So we're really looking at a massive increase of connected devices, and that's a lot of the talk around 5G, is around connecting all these devices as well as adding capacity. So I'm in agreement with what we talked about this morning for 5G, is adding more capacity, adding more devices, and providing better service. And then I have a summary chart, but really small cells can provide the massive capacity gains. Integrated small cells with Wi-Fi, additional capacity gains. SON, self-organizing network, allow the small cells to optimize in real time. And then network function virtualization for more efficient utilization of resources. And then with that, Peter, I'll turn it up to you and just jump through these slides that keep us on. There.
All right, perfect.
Thank you.
Thank you. Now, Brian Hendricks from Nokia. Do you want to go up there or go? Sure. All right.
Thank you, first of all, for the invitation to come here and speak. I'm a lawyer and an economist by training, so I'm a little bit out of place among the engineers on the panel. And asking me with those two backgrounds to speak within 10 minutes is a bigger challenge probably than the technology involved here. But let me just start by saying about Nokia, we have undergone pretty significant changes. The new company, the new Nokia, sans the device business for which the brand is widely known, is a pretty exciting company with 3 businesses, the most notable of which is Nokia Networks, which is our mobile broadband infrastructure business. We also have HERE, which is our location-based navigation company, which is going to be doing a lot with autonomous driving. And of course, we still have a very large legacy mobile patent portfolio from Nokia, which has got some exciting opportunities to repurpose some of that IPR to meet some of these challenges. We have a vision. We usually don't talk, at least internal to the company, about 5G. We started a few years ago talking about beyond 4G. And what we see happening is, and it began with a paper actually called Beyond 4G about 2 years ago, in which we predicted about a 1,000-fold increase in traffic on existing mobile networks by the end of the decade. we're on pace actually to hit that, if not exceed that. And so we talked in that paper about a lot of ways within the existing 4G technologies that we could address those concerns. And I know Peter is going to want us to speak to that in the panel discussion. But we actually think there are technologies within 4G, small cell, Mimo, licensed assisted access, and other things that we think can meet that demand by the end of this decade. But we have a bigger concern, which is the world's not going to stop changing by 2020. And when we start looking at things that are developing, you mentioned Internet of Things, well, you can see you've got everything from self-driving cars to augmented reality, live gaming from the cloud. Down here in the lower left-hand corner, sensors embedded in many different things for smart home, smart city. And not all of those things present the same issues for a network. There's different use cases and different needs. Some of them are highly susceptible to latency and packet loss. Some less so, where throughput, like gigabit instantaneous download service, is something that requires a great deal of throughput. And then all of these raise challenges about cost and power, and how can you get the coverage if the current generation of technology is not energy efficient and or affordable to deploy in networks, particularly in more rural areas. So we started looking at this and said, there are things 4G can handle, and there are many things we don't think that it will be able to solve. And so there's this something else, whether you call it 5G, evolved 4G, 4.5G, whatever your nomenclature is. There are some characteristics that we think are driving the research base here. If you look, we think by the 2030 timeframe, you're actually going to have a 10,000 fold increase in traffic. Lots of applications and services that consumers are going to want are going to require less than a millisecond of latency. Lots more devices. You're going to want gigabit per second peak data rates. You're going to want issues that you currently have about diminished throughput at the cell edge to be mitigated. Again, the energy efficiency and the cost of some of those technologies that our carrier customers are asking us to address go a long way in terms of what we need in the research base. And over here you can see some of the limits. You know, energy consumption, cost, coverage problems. You might not be able to see that because it's in white, latency, and some of those are issues. And so when we started looking at beyond 4G, what we see is that this is going to have to be much more flexible, much more diverse than previous generations of networks. There's going to be a lot of use cases, as I mentioned, some high data rate, some extremely low latency, low energy and cost. Our engineers say luckily not at the same time. I'm less optimistic. I think there are going to be instances where you need all of the above. And the key decision principle for 5G technologies, we believe, is going to be reliability. That's the low latency and dealing with issues of packet loss and diminished performance at cell edges. Flexibility, and more importantly, scalability. It has to accommodate all of these use cases and be affordable and scalable as a solution. We don't believe the direction that 4G is going alone will be capable of solving the challenges. And so, like others, we have begun to take a significant look at the enabling technologies, the research base that needs to be laid. But I put this chart in here simply because if you look at the bottom, this is sort of evolved 3G and 4G. There was a big focus on macro base stations and optimizing spectral efficiency, and of course, spectrum's always important. We need more of it. By the time we got into 4G and as we go forward, the focus is a little bit less on spectral efficiency with a shift more towards density of deployments to get additional coverage and capacity. 5G, on the other hand, in our view, there's going to be a bigger focus on spectrum, but not just where we've typically looked. There's going to be a need to look up in higher bands where there's going to be bigger blocks available to do things like millimeter wave, and there's some backhaul capabilities. There are trade-offs there because of the propagation characteristics of that. I mean, I told you we're trying to control cost and power, and that's certainly more difficult when you're dealing with spectrum up in that area. And ultra dense, if massive is one way of looking at it, ultra dense is another adjective that basically means all of the above technologies, macro base stations, small cell, Wi-Fi. All these technologies are going to have to work together in that future generation of technology to provide the best coverage that you can get. And the result of this was, at least in our mind, there was always a perception about capacity in certain generations of technology. 3G, there were limits. 4G had more capacity, but still limits. The perception, at least in some, and maybe this goes to Peter's question later about is 5G overhyped, is the perception is that we can do so many different things, and the promise is with technology breakthroughs that capacity is going to be much more cost effective to add and much more available to deal with the challenges going forward. I almost dropped this cell because I think it's, or this slide, but basically you can see the spectrum that we're looking at. Next step basically means it's stuff that we're currently working on and thinking about. Some centimeter wave, small cell, Mimo was mentioned a couple of different times, interference coordination. Exploration, that doesn't mean that it's way far off, it just means that that's part of the current research base that we're looking at along with a number of other companies in our space as we set up organizations like 5GPP and Metis and others to start asking these questions. This is kind of how we see it fitting together. It's not an either-or situation where we have LTE and you can evolve LTE, therefore we don't need to be doing something else, or we should just immediately start focusing on 5G and not focus on getting the best that we can out of our current generation of technology, because not all of our customers, anyway, are similarly situated. Some really need relief now, given their network characteristics, and they want us to focus here. Some of our bigger customers are looking in this space, and we see them dovetailing with one another out around release 14 and 15, when you'll begin to see the first releases for 5G. And just to give you a quick synopsis of the timeline, you can tell one of my engineering colleagues put this together. Basically what you'll see is 3GPP activity on 5G has been pretty limited so far. A lot of this discussion has been taking place outside of 3GPP. However, we believe that you will start to see the first releases out of study items out of 3GPP in the 16, 17, 18 timeframe. So that really gets to the question of when are we going to start to see commercial deployment of 5G technology, and we certainly think that will be after 2020 and picking up pace thereafter. Just a couple of things to mention as far as Nokia is concerned. We are a sponsor and partner with NYU in the Brooklyn 5G things that are going on. We had one in April. I don't know, some of you may have participated in this. We thought it was pretty successful for a first go, 150 participants. A lot of discussion around things like millimeter wave communication, where people are starting to coalesce around the view that this is suitable for backhaul and small cell. Nothing earth-shattering came out of it, but getting some agreement on those areas for further research is sort of important, and so these will continue to evolve going forward. We've been selected to chair 5GPP going forward. I think Ericsson is the leader in Metis. So the infrastructure vendors are obviously very interested. We're not going to bet everything on 5G technology because, like I said, our customers want things now. But ultimately, we think about 5G as a all of the above approach. It's going to utilize all of the existing technologies like LTE. It will be backward compatible. We see Wi-Fi will have a big role going forward. Lots of different radio access technologies will be involved. But probably the different element that we see as a role for a lot of different spectrum than we have seen in the past. Particularly the higher bands frequencies is areas where we think has great promise. So in the interest of getting us back on schedule, I will stop there. I do hope we will have a chance to talk in the panel a little bit. You saw policy in my title, so I care a great deal about the right policy environment for 5G. It's not something, we're talking about the technology, but one of the things that I talk with the FCC and others about all the time is you have to have the right policy environment to encourage 5G research. And lots of issues of the day that we're dealing with right now, from net neutrality to standard essential patents, all go directly to what type of environment you're going to have. Because at the end of the day, on the network side, there's only a handful of companies that are driving this research. And we've all struggled, and we've seen flat spending, and we've seen carriers facing down declining or flat average revenue per user and return on capital employed. And so there's a real question. It's wonderful. We know what research needs to be done. There's a real question about, do you have the right policy environment that enables a business environment that lets us do that research? So we can talk a little bit about that.
All right, we will. All right, next presentation is from Hank Kafka of AT&T. Should just go directly to your slide.
All right, just jump ahead. All right, just going to do it from back there. But there we go. Okay. All right, good afternoon. Thanks. After sitting through the session so far, you're probably aware that consumers have pretty much fallen in love with mobile data. Started about 7 years ago with the birth of the smartphone era, and it's just kind of taken off from there. We got app stores created, streaming video over mobile became mainstream. New devices like tablets have hit the market, and as you can see from the chart, most of the forecasts show continued growth for data. And we continue to build more capable networks utilizing LTE, which consumers have embraced wholeheartedly. In fact, mobile broadband has been one of the great success stories in technology. As these networks have grown globally, so have the number of mobile subscribers overall. The number is expected to continue to grow strongly. Through 2019, most of that growth is going to be on LTE connections, with 2.6 billion LTE subscriptions expected by the end of 2019. And with smartphone penetration now reaching saturation in the US, we're still looking at huge growth in numerous areas. These are some examples. Take connected cars, for instance. This year, General Motors is going to have 33 models equipped with OnStar that will be connected by 4G LTE. And according to Analysis Mason, 62% of new cars sold worldwide are going to have embedded connectivity by 2018. Wearables is another sector that's on the verge of exploding. In the last couple of months, we've seen announcements from Samsung, LG, Timex, and Apple about their connected watches. The Timex Ironman 1 GPS Plus has a 3G embedded SIM in the watch itself. It's designed for runners and can take the running and exercise data and upload it directly to the web without having to go through a smartphone. Its built-in messaging functionality is also in place, so you don't have to carry that smartphone when you're running. And it's just one of many such devices that are coming to the market. As you can see, IDC is forecasting a 78% annual increase in wearables until 2018. And the M2M sector also continues to be a strong growth area, whether it's electric meters or parking meters. All sorts of machines are talking to the cloud and to each other, and analysts are forecasting 24% annual compound growth until 2018. But as the demand for more coverage and capacity grows, carriers are turning, going into LTE and then LTE Advanced, which is the next evolution of the technology. It's got a great range of capabilities to enhance mobile experiences with carrier aggregation, heterogeneous networks, and the higher order Mimo, multiple inputs, outputs, or the number of antennas per transmission that are showing up in LTE Advanced as a precursor to much more of that showing up later on. As you can see from the chart, the capabilities are being rolled out now by the industry and will continue over the next few years. They'll lead to better capacity and better customer experience. So if we put kind of together the trends, we get this rapid growth going on in things like connected cars and wearables with embedded technology, and then the steady rise of data use by our smartphone and tablet customers. The industry continues to use a variety of techniques to meet that demand. We're densifying the networks by deploying more small cells and by deploying distributed antenna systems. We're rolling out techniques like EICIC, or Enhanced Intercell Interference Coordination, which helps reduce and overcome the interference in these HetNet environments. And we're tying it all together with HetNets and self-optimizing network capabilities, which give us higher capacity, fewer dropped calls, and better customer satisfaction. All these devices also place growing demands on the core network. And a new technical approach that we've been pursuing is network function virtualization, as Andy mentioned. It's basically building a smart, cloud-like core network that can address business changes and customer needs rapidly and dynamically. NFV is going to give us a new just-in-time approach to handle these increased traffic demands in the core network more efficiently and support network efficiency. We're using the latest network design techniques. We're actually moving from hardware as the focus to software to to make the core network faster, simpler, and more scalable. But make no doubt, the massive growth of data also means that network congestion is going to remain a problem as we go into the future. Mobile broadband providers face some unique and interesting technical challenges, including spectrum resources, differing handsets with differing capabilities in each handset, differing spectrum bands, differing technology platforms, and each user's constantly changing channel conditions, to name but a few. In addition, we face varying numbers of users at any one time and in any one place using a plethora of different applications, many of which can be bandwidth intensive, and this can place strains on the cell site or the cell sector. So these challenges demand far more complex and aggressive network management capabilities than fixed broadband requires. Self-optimizing networks are one recent example of how the wireless industry is developing approaches to adapt to these challenges, and operators need the flexibility as we go forward to explore innovative solutions, moving from LTE to LTE Advanced and onto 5G. Thanks.
Thank you very much.
I'm going to, rather than bore you with my 10 minutes of prepared remarks that looks remarkably like what you just seen, but like Andy said, I do have some very nice slides, so I'm going to make sure that you see my slides, but I'm just going to basically hit the high points. The long and short of it is Qualcomm agrees with everything that you've heard, and Qualcomm also likes the word massive, and Qualcomm's view of massive is 1000x. So just briefly, how are we going to get to 1000x? Basically, simultaneously taking the three items on this middle arrow. Higher efficiency, I'll get into briefly what we mean by higher efficiency, but it's basically using the spectrum in a smarter way when you know what the users are demanding, being able to bond different channels to provide a bigger pipe, because when you service a particular user in a quicker way, you have more capacity to service a lot more users. More spectrum. A lot of us in this room are working hard with the FCC to repurpose the 600 megahertz band from TV broadcast to mobile broadband. That's one band. The 3.5 band is another band. And like folks have said, we're also looking higher. You know, if there's spectrum that can be used for mobile broadband, we want to use it. So it's just a way of figuring out what tools are appropriate and what is the best fit in order to open up bands to have more capacity. And small cells, small cells, small cells, you've heard all the benefits of that. I do have a few nice pictures about it that I'll go through quickly. So how are we going to get more spectrum? Three ways. On the left, cleared exclusive licensed spectrum is the gold standard. That is what we should be working towards, because that gives the mobile carriers the most flexibility. When you're sharing spectrum with another party, you're restricted in what you can do with that band. You need to worry about, if you deploy a new technology, is it going to share spectrum okay? Are you going to be affected? Is that new technology going to be affected by whoever you're sharing the band with? So sharing introduces uncertainties and also limits flexibilities. So that's why exclusive licensed spectrum, I said, is the gold standard. Unlicensed applications, where unlicensed spectrum can be used for Wi-Fi and new technologies like LTE unlicensed, which I have a slide on. That is a very important capability as well. And in the middle, Qualcomm has been working with the wireless industry on a regulatory framework called ASA for Authorized Shared Access, which is a simple binary framework. When the incumbent user isn't operating, that spectrum can be used on a licensed basis for mobile broadband. You've heard all this. You can read it. It's a cute little slide. But, you know, LTE at this point is progressing. There's a lot of capabilities. Interference cancellation, self-organizing networks, carrier aggregation, supplemental downlink. All of these tools are part of the LTE ecosystem. One of the important things is once the technology is available, you could deploy it on FDD and TDD networks. This is an example showing, you know, carrier aggregation. One thing I can say is a few weeks ago it was announced Qualcomm and Nokia networks had an interoperability demo where they bonded 3 separate channels to have a 40 megahertz channel, and they were able to put through 300 megabits per second, which is a hell of a lot of capacity. And you're going to see more of that. Our phones are going to be able to receive over multiple bands simultaneously. And again, the end result is is providing an outstanding user experience. LTE broadcast. Some of you may be thinking, wow, so you're taking spectrum from the broadcasters and you're going to use it for broadcasting. Well, in certain instances, LTE broadcast is the way to go, where you can actually, on the fly, repurpose spectrum, use spectrum for a broadcast capability. When or why is that important? Well, you're at a football game and you want to watch a star camera of, RG3 if you're a Redskins fan, or you want to see a replay. And the provider in that stadium knows that X number of people want to watch the star camera or want to see a replay. It is much more efficient. Once you move above 2 to 3 users, it is much more efficient to service those users using LTE broadcast for that instant of time in that area. Also, it's very useful for public safety messages. You want to provide a message to everybody where you could send and tell them stay out of this area, or there's some issue going on, or alert a lot of users of a particular event or disaster or what have you. It's very useful in those types of applications, software downloads, etc. And LTE unlicensed is, one of the technologies that Qualcomm is working on is actually deploying LTE in unlicensed spectrum. And what we've learned is the throughput is better than plain vanilla Wi-Fi, and LTE in an unlicensed band is actually a better neighbor to a Wi-Fi system than a second Wi-Fi system. So you could actually have better capacity, better throughput, and be a better neighbor to a Wi-Fi system. Small cells, they are going to be probably even smaller than this. And they could another interesting point is they could be integrated into your routers at home, your set-top boxes. And what we've seen, and I have a few slides, is exactly what folks have said. By deploying a very small number of small cells inside homes, you could actually provide pretty good coverage in an entire community. With very low penetration rates, you could provide very good level of service. And if you increase the penetration to about 20%, you could provide extremely good service in a particular area. And this is just a summary slide. How are we going to get to 1000x? We're going to do, like everybody on the panel has said, everything as soon as we can and as often as we can. Thank you.
All right, that was great. So I'm going to ask a few questions, and then I'll turn it over to the audience. I actually learned a new term today, which is always delightful. So I've heard of Cloud RAN, but today, and I've also heard the term NFV. In fact, the Wireless Technology Association had an NFV workshop fairly recently, but I hadn't heard the term Cloud Core. That's pretty cool. The Cloud RAN combined with the Cloud Core. So my first question is maybe to you, John, or the entire group. You mentioned the 1000x improvement. So my specific question was, what gains in capacity and performance can we expect from LTE the rest of this decade? So when you said the 1000x, are you talking about LTE by 2020? Is that the Qualcomm view?
What our view is, in order, and I didn't explain this, but 1000x sounds like a lot of capacity, but basically there's been a number of studies that have shown that the data demands are doubling each year. And if you double data demands each year, 2 to the 10th power, for those engineering nerds, like 2 to the 10th power is 1024. So that's how you get to 1000. Actually, you get to 1024. So it's basically, Peter, small cells are a huge piece of that, but We also need more spectrum to provide capacity, but LTE-based small cells are very important, more spectrum, and also opening up bands that are not going to be cleared for exclusive use anytime soon, such as the 3.5 gigahertz band, which is used up and down the coast for federal radar systems. When the radars aren't operating, you can operate a mobile service using small cells really close to the coastline. So it's a combination.
All right. Does anybody want to add to that?
Yeah, I was just going to say, I think some of the SON techniques, that's really what we're going to see a lot of in the upcoming 3GPP releases that are coming out. Is the focus, originally the small cell definition was in release 8, the LTE small cells in release 9. Some of these things we heard earlier from Brian on the EICIC was using the X interface to start to coordinate the small cells with the macro cells. And so the self-organization capability, like we saw in the keynote this morning, being able to coordinate capacity is going to be key. And I think from now to 2020, it's going to be a lot of focus to add capacity that way with the existing LTE technologies.
All right. So it sounds good to me. We'll get the 1000X from LTE, and I distinctly wrote down that NTT Docomo said that the objective for 5G was an additional 1000X. So I'm hearing between 2010 as a starting point and 2030 as mature 5G deployment, a 1 million X increase in capacity. I mean, it's conceivable. And certainly if that were to materialize, the earlier question today of how many people could move from wired broadband to wireless broadband, well, that percentage, which is less, maybe in the 10 to 20% range today, could certainly go over 50% in my view. Anyway, that is looking ahead very far, but shorter term, I'm interested, Andy, since you just commented on small cells, what is the time frame for large-scale small cell deployments? Right now, when I look at projections of small cells, I hear tens of thousands of small cells, which is very respectable and is going to give us a significant capacity increase. It only takes a few small cells per macro to get a huge gain. But meanwhile, we're seeing Wi-Fi hotspots being deployed in the millions. What's your view? When do we get, would you be willing to hazard a time frame for going from tens of thousands to hundreds of thousands to ultimately millions? I mean, you must have like an image in your mind of how that happens.
Yeah, I mean, I think it's really interesting. We saw probably a handful of global mobile network operators deploying femtocells, which is for the original use case, which was basically coverage. It's a really nice, easy way to provide coverage where you don't have any. And certain operators have more of a coverage challenge than others, and depending on the frequencies that they have, as well as the maturity of their network build out. But we haven't seen as many. It's not like every network operator decided to go with femtocells. A lot of them would prefer to just turn up the power, on the macro. But with what we call urban cells or outdoor small cells, I don't really know if there's any operators that aren't making use of these, because it's part of the toolkit. So it's like you said, it's not necessarily that an operator is going to deploy 1 million small cells next year. It's really rounding out coverage areas, and somebody earlier, I think it was Brian, mentioned the densification term, and that's really what the small cells for capacity, for this massive capacity, when you start to need to densify the network, that's when you start to put the small cells in. You can see quickly with only 4, you're adding 50% of the macro becoming macro up. So you don't really need that many. The key is putting them in the right spot. And then the elephant in the room, we talked about this on the breaks, I didn't put it in my charts, is the backhaul question. Mm-hmm. And you really need to have where you want the best place to put the small cell isn't necessarily where you have the backhaul. And now with Cloud RAN, now we not only need to talk about backhaul, we also need to talk about front haul. So, fiber is the best solution. It's got the most capacity. It's the fastest. It handles, as wireless evolves to, 1 gig and above, you're not going to service a small cell with a cable modem. You're going to need, something a little bit more powerful. And that's where I think we're going to need to see some innovation, because the cost of fiber and then the location where the fiber is 2 areas that need to be looked at. So part of our work on Cloud RAN or NFV for the radio access network. As in the keynote this morning, the new RAT, which is looking at what can we do on the interface between the radio head and the baseband to either compress or make it more efficient so that we can get some of the benefits of NFV in this Cloud RAN type of a network.
I would just add very quickly, Andy alluded to a couple of challenges to wider scale deployment of small cell, and certainly some of our customers here in North America have that very problem when it comes to access to fiber for backhaul. At the risk of making Hank twist a little in his chair, they're not incumbent local exchange carriers that have most of these buildings wired. So there's a regulatory question there that someone else is going to have to sort out, but there's also a cost issue. We're always getting pressure from our operator customers to reduce the power and the cost of deployment. And the financial picture out there is one, as I said, it's easy to point at a profit and loss statement for a carrier and say they're doing extremely well. The truth is, it's a very difficult environment. And so we think you're probably not going to see mass scale small cell deployment any earlier than mid-2016 and possibly after. And that's large scale. I mean, certainly, as Andy says, there's some of that already going on.
So large scale to you means
Massive.
hundreds of thousands? All right. I'm finding it hard to pin down a number here, but maybe that's because there's so many unknowns.
We do publish a report, a regular report on the small cell
Right,
website. So I would say, look at that if you want to see numbers
Yeah.
per year of units. I don't have that memorized, and I'm not going to quote it because,
We would
don't wanna be
certainly be
wrong.
excited to see the number in millions, as we would be providing a lot of those. But
So Hank, when you look at capacity gains, is small cell at the top of the list, or is it more spectrum, or do you prioritize your tools in any particular way for capacity gain?
No, I wouldn't say we prioritize it. I think they're all important factors. It really is a kind of a full toolkit set, and you've got to look at the right thing for the right time and the right place. So, small cells, I think it's going to be a gradual process. We've deployed a lot of femto cells.
Right.
And deploying something that broadcasts in licensed spectrum is different than deploying a Wi-Fi hotspot. There's a whole lot of different rules and approaches you've got to take. So it's really not just the device itself, but there's kind of an infrastructure and ecosystem that has to go along with it, and operations, processes, and everything else that have to get set up and managed. But that's an important tool to put in place. It's really getting that whole toolkit. And, as you deploy small cells, depending on where you put them, you've got differing degrees of interference management to deal with, and that would require differing degrees of sophistication of interference cancellation and self-optimizing, self-organizing network capabilities. So I kind of see the small cell as a ramp-up process as they develop more capabilities and we get more experience with when and how and what it takes to deploy them and get them into place.
Right.
Yeah,
Okay.
one thing I'll add is, like Hank just said, in order for the small cells to really be a massive deployment, they need to take advantage of the tools that are now available. Self-organizing networks, interference cancellation, they truly need to be plug and play. You need to add it to the network, kind of like a router, Wi-Fi router. You don't worry about it, it just works. You enter your password, you set it up, and it works. And these small cells need to operate in the same way. Qualcomm did a demo at a NASCAR racetrack where we went in and installed a handful of small cells and did no network optimization, no planning. Wherever we could put one and we had backhaul, we put one, and it was in a pit area, which is remarkable. You wouldn't think that there would be that much of a data need in a pit area, but there are massive needs for them to actually connect to the cloud and what have you. And we showed that the gain was, several orders of magnitude just by having these small cells self-optimize and work. And that's the way, for it to be successful, it needs to be that way. You can't you can't get on the phone and say, my small cell ain't working, have the guy roll a truck. It's not, it just has to know where it is, it's part of the network, and work in conjunction with the other small cells that are in the area. That's the way it's really going to be very successful.
Yeah, so my takeaway is that the technology becomes more sophisticated through self-optimization, self-organizing, but then also operators gain more experience in deploying cells. There's still the problem of site acquisition. We heard earlier today about the problem of just adding a cell to the top of the building and an operator giving up. So just getting to all the light poles and all the obvious places to place small cells is going to be a learning experience in itself. And the backhaul technologies will improve, greater choices. So yeah, it looks very promising, but it's not an immediate slam dunk either. So switching gears a little bit, is 5G being overhyped? Should we be concentrating more on short-term problems, or is this the right time to be thinking about 5G? Any views from any of the panelists?
I don't think it's been overhyped. If anything, it's been incorrectly hyped.
Okay.
I mean, I think that was the essence of what I was getting at in my slides, is that there was an impression created that this technology, the research base had already been laid, it was available, and that it was going to be imminently deployed. And in truth, all of the promises and benefits we think are clear. They're just not going to arrive on the timeline that people assumed. And so the answer is you have to do both. And from a customer standpoint, we have to do both, because we have carriers that have needs today, not in 2030. So it's both. I don't think it's been overhyped. I think it's just been incorrectly hyped.
All right.
One other thing I'll add is it also has been mishyped. I don't know when, but another company who will remain nameless was actually calling a 5 gigahertz product. This is 5G. And,
Oh, yeah, and Wi-Fi, which is
in
very
Wi-Fi.
misleading. Correct.
Yeah. So.
And to give them credit, Wi-Fi is in its 5th generation, but to call their technology 5G definitely confuses a lot of people, I think.
Yeah.
Yeah, and I would just add, I really like what I've heard at the conference here today, because everybody sits in their own cocoon, and everybody has their own opinions, and so it's good to hear that we're aligned on some of these topics around 5G, what it is, what it's not. Going back to history, I mean, what's the voice solution today on all of our LTE phones, right? It's still 3G fallback circuit switch data. I mean, VoLTE's coming, but there's a reason why it didn't come, why it's not here already today. And as we evolve the network, I think LTE has really long legs. I think the technology that exists with LTE, as we add in carrier aggregation, as we add in massive MIMO, as we add in a lot of these other techniques, small cells, things that we've been talking about, LTE is going to be around for a long time. So what is 5G? It gives us the opportunity to really look at 5G as the Internet of Things, because that's kind of the original hype that I was hearing from the definition of it. People were, oh, it's really going to be the Internet of Things. But now what we're hearing a little bit today is that, well, maybe it's just an evolution, of the existing technology that we have. So it sounds like the jury's still out. If it's going to be, an evolution of all these things we talked about today versus a whole new, because in the past, every time it was a new generation, was a new air interface. It was analog, then it was TDMA, CDMA, WCDMA, OFDM. So people are saying, well, in order to call it 5G, it has to be a new radio interface. But today we're saying, well, maybe it's just a combination of, massive MIMO and these other things. So
There's one more point on that. Yes, LTE has long legs, but the reason that I suggested we don't view it as the perfect long-term solution, and there are a couple of reasons. I mentioned some of the regulatory challenges. The other thing is standardization is essential for scale, and you're many releases in to LTE. The more features you add, the more obfuscated the standards become. In some cases, 5G provides us with an opportunity to start with a clean technical slate and basically develop networks that are all things to all people for all use cases at all times. And so that sounds like that plays into the overhyping, but at the end of the day, you do have some institutionalized limits to how far we can go with LTE, technology gains notwithstanding.
All right. All right, so I think just to make sure that I have enough time for tying together technology and policy aspects, I'm going to ask this next. Well, actually, I'm going to run out of time for the audience. So maybe, Brian, very quickly for you, you were itching to ask about what policies should we have to nurture the development of this industry.
Sure. So I can actually send you a very short 2-page policy paper that we just produced on 5G, at the end of which there is a section about policy enablers. And from our standpoint, there are 3 that we think currently we're looking at in the regulatory environment. The first is net neutrality, which is a topic I hate talking about, but is an essential one, because if the commission gets it wrong, I mean really wrong, it will destroy a whole potential area of value creation for wireless operators that will flow through to the infrastructure business. We can talk offline about what getting it wrong looks like. Standardization is key. There's currently a significant push by handset companies and others to destroy the value of my intellectual property that is embedded in standards, making it very unlikely that we will continue to put our best technologies in standardization. And so those are 2 right off the top that I would mention we have to get calibrated correctly.
All right, thank you. All right, let's turn it over to the audience for like the next 5 minutes, 6 minutes or so, if there are any questions. Carolyn?
You can always defer to someone else in the back.
That's right, go ahead.
All right, so I'll take the bait. Can you elaborate on what getting net neutrality wrong looks like from your perspective?
Sure.
Surprise, surprise, Peter.
Sure. So one way you would get it wrong would be if, as some of the commission staff recently suggested, that wireless and wireline services are exactly the same. They are not, in very demonstrable ways. And the same non-discrimination principle, unless it is exceptionally well written, is probably not going to allow operators enough flexibility to deal with the challenges that they have. The other issue is around something that Chairman Wheeler said, which had people lighting themselves on fire in front of the FCC, and that is the concept of prioritization. We believe at Nokia that, and again, I don't serve end user customers, but dealing with our customers and the value creation, we believe with application-aware radio access network elements that we have, that there is an opportunity to create a tremendous amount of value, preserving fundamentals of open internet with transparency and limited prioritization for OTT services and choice for consumers. It's not an either or. It's not a all data is data and has to be treated the same, which is a nonsensical proposition to us. But if you have these hard and fast cuts that say no prioritization under any circumstances and or wireless and wireline are the same and you can't throttle, you can't do anything except a bit is a bit, that's getting it wrong.
All right, Stacy?
So,
And say who you are.
I'm Stacy Black with AT&T. So is it the, and I'll just direct this to the entire panel, is it the vision that today when we look at our connected home or an environment like that, we're using a variety of different air interfaces, licensed and unlicensed, to create a complete user experience, and whether it's Z-Wave for home security and Zigbee and whatever. Is it the future vision of 5G to where everything is going to be one particular technology? Will it all be licensed, or do you still see a coming together of a variety of different air links?
I'll take that first, just really
ahead,
briefly.
John.
I hope not. I hope it's not a single thing. I hope that, because I think that's how innovation occurs. I'll give you the example of LTE unlicensed. I mean, we found by deploying LTE in an unlicensed band, you can provide a great user experience, and it's less harmful to a Wi-Fi user, and it provides a better throughput than a Wi-Fi connection. That's just one example. And the FCC is not looking to do this, and they shouldn't. If they said, oh, unlicensed means Wi-Fi, that would be a problem, and that's not the way to go. They should do what they're doing in the unlicensed bands, define power levels, bandwidths, and let 1,000 flowers bloom. And if there's the 5G technology and that could be put into an unlicensed band in the future and it's better than LTE, great. Qualcomm, I hope, would be one of the companies that would develop that.
Yeah. I mean, from Nokia's standpoint, it can't be the former. It's got to be the latter, all technologies. The two enabling principles I put up there were flexibility and scalability. That means you have to have multiple technologies involved, from Wi-Fi on down, unlicensed uses, just simply from a cost management perspective, making it scalable, and the flexibility to support things. So I mean, our vision is similar to John's. It has to be all of the above.
Yeah, and since you talked about the connected home, and we had the example of the instant replay at the football stadium. We'll talk about in the connected home, you want the lights to come on or the air conditioning to come on or go off when there's no mobiles, nobody's at home. You want to have the hot tub come on, and whether it uses Zigbee to do the hot tub and Wi-Fi to do the garage door opener, the consumer doesn't really care. They don't want to have to worry about that. So what we've been doing just with Wi-Fi is doing like the channel bonding, where you have a large download and you need more than just what the LTE pipe can give, or you have intelligent networking, where you start to make intelligent decisions, make use of all the resources that are there, whether it's a Wi-Fi pipe, a Zigbee pipe, LTE pipe, a 3G pipe. And so that's where I think the network of the future needs to be an intelligent network, where it's smart enough to make those decisions, like the original iPhone 3G, where you had to go on the hotspot. You're walking by a Starbucks, and if it was really busy or didn't have a good backhaul, it worked like crap. But the consumer doesn't want that. They want the best user experience, but they don't want to have to sit there and program the phone. Oh, let me try this one. Let me try that one. It just has to work seamlessly, and that's really what we need to be looking at for the evolution.
Yeah, there's also physics that just get involved as you come across it. So this is an example. If I, am getting a massive MIMO approach, I could take something antenna about the size of the sheet of paper and put a lot of antenna elements on it, right? And if I'm operating that at, say, 60 gigahertz, I can build a nice antenna that, maybe around this size. If I tried to use exactly that same antenna configuration at 4 gigahertz, 15 times lower frequency, it's 15 times bigger. It's about the size of that screen. So the technology that you use needs to be optimized to where it's located. That's one of the reasons that you hear kind of, the potential for a different RAD approach at 5G is because the physics tend to be different when you get into the millimeter wave bands. And I think that combination of a lot of different ways of combining various parts of licensed spectrum along with unlicensed and other transport capabilities is the direction we're going to see moving forward.
All right, let's take one more question. Emil, or Burj, you're close to the mic.
I was wondering what the implications of coordination between macros and small cells mean. I've heard different vendors interpret it in different ways, and perhaps operators as well. Does it require that I deploy Ericsson base station, Ericsson small cells if I've already deployed Ericsson macros, or can you intermix vendors effectively and still get the benefit of the coordination? And then similarly, if I were to think bottom up rather than top down, and I were to look where I do have backhaul, where I do have the ability to connect small cells to broadband networks, and go back to my BYOB notion. If Comcast wanted to approach T-Mobile and say, sure, you're giving out small cells for your customers to create stickiness, what if I were to integrate them into my Wi-Fi hotspots and provide an integrated Wi-Fi small cell and put them on my broadband networks and then give them very high broadband backhaul speeds? These kind of hybrids, rather than thinking one way about things, how do they fit into the prognostication of how many small cells there might be?
All right, well, congratulations, you stumped the panel.
Let me answer the question in a non-technical way and let one of the engineers answer the technical side. I mean, certainly as the more disruptive company in North America, since we're sort of a late arrival in 4G, I would certainly love nothing more than to be able to go and sell Hank all kinds of small cell technology for AT&T. I think I've always viewed it as largely a logistical challenge when you already have one or two domain vendors in your network, and then all of a sudden you're dealing with yet another vendor for network equipment, and just the cost and the management of those relationships can become very difficult for companies to do. As to whether or not there is a technical reason why we can't, given standardization, I don't know, honestly.
Yeah, and I would say most of the small cells that are being deployed today are multi-technology. The incremental cost to have a Wi-Fi board and an LTE small cell is it's rounding area. It's trivial compared to some of the costs Brian talked about earlier, that are real things that the operators want to focus on, is getting the deployment costs down.
Not vice versa, right? To have licensed spectrum, LTE or...
Well, earlier, I think it was John was saying, in the future, we're going to see, USB and a set-top box. You can add a femtocell into your set-top box just with a little USB plug-in. So we've already seen some of those form factors on the market, a couple of years ago. So, the numbers are there,
Yeah, I think the ultimate vision will be a device that will know what it wants to transmit, communicate, and use the best band. Whether that's Wi-Fi, whether that's LTE, and it'll be, probably in a form factor that's, like this.
And that's when you can get millions and, the economic
Yeah,
support.
yeah.
You tricked us because he had asked a two-part question, so we're all sitting here trying to remember what was the first question. I just remembered it. Wait, oh no, I forgot it again. What was your first? No, you're saying something about how are these things going to work together with the SON. And so it's going to be really funny when we look back 10 years from now at the original femtocells. I mean, it was so disruptive, the small cell technology, when it first came out. But the reality of it is, we said it wasn't standalone because we had TR69 and you could manage it remotely and download software, turn it on, turn it off, bill for it, all that. But the reality of it is it didn't talk to the macro at all. The original cell phone, the decision was, okay, who has the strongest signal? That's where I'm going to go. If the macro is stronger, I'll go there. If the small cell is stronger, I'll go there. And then now as we're evolving through these releases and adding all these techniques like EICIC and all these other EIEIO type, X interface and everything else, I mean, it's getting really sophisticated. And really to get to the 5G stuff we talked about this morning, the sophistication is going to increase even more. So we'll look back and see these original femtocells like stone tablets compared to what we're going to have over the next couple of years with all the things that are coming out in release 12 and 13. There's a lot more techniques that's going to allow us to move capacity around. And from the previous question, some of the stuff is proprietary. I've seen individual vendors try to keep it their own proprietary, and it does really good stuff. Like you're in a really strong signal, but you still want to offload to the Wi-Fi, and being able to do things like that. But the hope of the industry is to standardize so that it can be plug and play. I know the operators are probably a little bit more interested in plug and play, and the vendors are more interested in differentiation. And that's just the way. That's economics, right? Capitalism.
One thing.
All right, one final comment. Go ahead.
Yeah, I don't think small cells are going to, as we go forward, they're not going to be one small cell and that's it. It's really going to, it's a family, and in fact, it's already a family now. You've got small cells that are essentially like picocells that are mini regular base stations, and you've got small cells that are kind of like, we'll call them grown-up femtocells. And those are two different solutions. They have two different integration implications, two different ways of managing them. I think that's only the start. So, the small cell that you might put in a basement of a building that has kind of no RF connectivity to anything is going to look a lot different than if you're putting up an entire array of small cells around Times Square and they're all communicating out in the open. So it's just going to be a diversity of configurations and types, and the answers to the specific questions are going to vary with the type.
All right. It really hurts me to stop this panel because the discussion is so interesting, but we do have a schedule. So we're going to take a 10-minute break and resume. I have 2:55 on my watch. We're going to resume at 3:05, and we need to stay on schedule, so don't go too far away. See you in a few minutes. And thanks to the panelists.